This video is a tutorial on hypothesis testing concerning two populations. Please read this question few times after pausing the video and try to solve it based on your learning. It is given that population 1 has mean of 80 and standard deviation of 5. It is given that population 2 has mean of 75 and standard deviation of 3. We have to find out probability for the difference in mean to be in a range for the samples taken from two populations. Here, hypothesis testing involves testing on sample means when the population standard deviation is known. Therefore, the test statistic used will be t-distribution. The difference in sample means has to be at least 3.4 but less than 5.9. This is equal to the difference to be more than 3.35, as 3.4 is included, and less than 5.85, as 5.9 is not included. Now, the expected value for the difference in sample means is equal to the difference in population mean. This value comes out to be 5. The standard deviation of the distribution of difference in sample mean can also be calculated using sample size, as shown here. Now, we can find out the corresponding z-values for 3.35 and 5.85. The two z-values turns out to be minus 1.48 and 0.76. Now, we can read the probability between these two z-values from the z-table, and this comes out to be 70.7%. Please read this question few times after pausing the video and try to solve it based on your learning. Here, we are interested in knowing if there is a difference in process yields between two catalysts. If there is no difference, then we can use catalyst 2, as it is cheaper. Therefore, our null hypothesis will be that there is no difference. Alternate hypothesis is that there is a difference. Since the population standard deviation is not known, the test statistic will be based on t-distribution and is shown here. Here, the expected value of the difference in population mean is 0. The significance level is 0.05. Therefore, the critical region will be the absolute value of t, for a significance level of 0.025, and degrees of freedom of 14. This value comes out to be 2.15. Now, we can calculate the absolute value of our test statistic, and it comes out to be 0.35. Since this is not in the critical region, null hypothesis is accepted. We can also calculate the p-value. The p-value comes out to be more than 0.5, as a value of t, for 14 degrees of freedom, of 0.692, corresponds to a p-value of 0.5. Since our t-value is lower than 0.692, the p-value will be higher than 0.5. Therefore, such a high p-value also supports the null hypothesis. We can therefore conclude that there is no difference between the process yield for the two catalysts. Since catalyst 2 is cheaper, it is more economical to shift the process to catalyst 2. Please read this question few times after pausing the video and try to solve it based on your learning. This is an example of paired data set, as both the values are from the same subject. Therefore, the first step will be to derive the new differential data set by subtracting each value as shown here. Now, we calculate the mean and standard deviation of the differential data set, and the values are given here. Now, we have to find out 95% confidence interval for the difference in mean. Since population standard deviation is not known, we will use t-distribution for estimation of required confidence interval. We can find out the t-value for a significance level of 0.025 and 19 degrees of freedom. This value comes out to be 2.093. Therefore, we can easily calculate the required confidence interval as shown here.